All right, guys, we're back again. More graphing, general rational, more rational functions now. This is kind of one step up from where we were on Monday and Tuesday, but you really need to make sure you know Monday and Tuesday how to find a vertical asymptote, how it shifts, things like that. So we're going to take it up one notch. Good news is we're going to spend 2 days doing this, so get as much as you can today. Try to get it all today, and if you are, it'll be great. Tomorrow you have it made, and we'll go from there. So dig in here, watch really closely. Okay, this is a big general slide right here that has all kinds of information that you need. I'm going to kind of run through it, and then I'm going to show you one example of each type of problem and then kind of summarize it at the end. So that's how this video is going to go, just so you know up front. All right, rational functions, they're going to look like this. Ones we did the other day, we had no x's in well, we did, but the degrees are always the same. And the numerator and denominator. Today what's going to happen is they're going to give you functions in your numerator and functions in your denominator. And the way the graphs are going to look is really going to depend on what the degrees are and where. Degrees meaning the biggest exponent on the top and the biggest exponent on the bottom. That's going to be your degrees of each. And the way we graph things is going to be very dependent on what those degrees are, what those exponents are. Okay, three things here. The x-intercepts of the graph, which are going to be important, are the real zeros of p of x, which means whatever makes the top or your numerator 0, that's where your x-intercepts are. So whatever makes your numerator 0, those are your x-intercepts. The graph has a vertical asymptote at the real zero of q of x. That means the same thing we were doing Monday and Tuesday. Sorry. Whatever makes the bottom 0 is still going to be your vertical asymptote or asymptotes. You could have problems where you have two asymptotes. I think we're going to see one here in a second. Here's where it gets a little crazy today. The graph has a most one horizontal, which is determined by the degrees. It's all about the degrees of your numerator and denominator. If the top degree is less than the bottom, the x-axis, which is the line y equals 0, that's the x-axis, is the horizontal asymptote. That's if the top degree is less than the bottom. Make sure you get that down. If the two degrees are the same, if they're equal to each other, what we're going to do is we're going to put the leading coefficient of the numerator over the leading coefficient of the denominator. So leading over leading. I wish we were in class. I have a great gesture for this. Leading over leading. If your top degree is bigger than the bottom degree, which is the third case, there is no horizontal asymptote. And the graph's end behavior is the same as that, which is, well, I'll show you what that means here in a second on the picture. Make more sense. Okay, so three rules. Let's go through one more time. If the top degree is less than the bottom, then the x-axis is an asymptote. If the two degrees, the bottom and top, are the same, you do leading coefficient over leading coefficient to get your horizontal asymptote. And if the top degree is bigger than the bottom, there is no horizontal asymptote. And you will see what that looks like in just a second. Okay, so I'm going to show you one of each of those cases and see if we can't get this going. All right. Directions, the same all day long. Graph the function and state the domain and range. And it gives you y equals 6 over x squared plus 1. Now the difference in this one and what we did the other day was now we have an x squared. So what I asked you on the video the other day, and people who, we did a little Google Meet the other day, the first question I always ask is what makes the bottom 0? Because that's going to be your vertical. In this case, you cannot make the bottom of that fraction 0 because if you square something, it's going to be positive. And if you add a positive number to 1, it's still going to be positive. So there's no way to get 0. So that means there's no vertical asymptote at all. Now, because the bottom degree, which is 2, is bigger than the top degree, which is 0, that means the horizontal asymptote is the x-axis. So your horizontal asymptote is the x-axis because the bottom degree is larger. All right, so what I did next is I typed the equation into the calculator just like that. I hope you can see that. I'm moving my graph now too. But that's how I typed it in. All right, that one. And then I did the table. I found my table here and found some points. I found 0, 6 is a point, which is up here. I'm going to graph these. 0, 6 is right there. Negative 1, 3 is a point. Positive 1, 3 is a point. I'm going to go like one more of each. Let's see. Negative 2 and 1.2, so about right there. And positive 2 is also, so it's symmetric, positive 1.2. So, and remember, the graph cannot cross the asymptote, which means our graph, I'm going to connect those dots, la, la, la. And it's going to look like this. It's going to go this way and that way, just like that. And there's what the graph looks like, using kind of doing what we did the other day. So we're adding horizontal asymptote rules today. Okay, I also got to tell domain and range. My domain, this one's going left and right forever. So I'm just going to say, because it's going left and right forever, you could say all reals, or you can write it this way. You can say it goes from negative infinity to positive infinity. The range, it's going up from the x-axis, but not forever. So I'm putting in parentheses because it doesn't touch the x-axis, which is 0. It goes up to 6 and actually touches the 6. So I'm going to put a bracket, and there's your range, everything between 0 and 6. Remember, domain is how far your graph goes left and right. Your range is how far your graph goes up and down. Hope that makes some sense to you. Okay, let's try another case. Second case is 2x squared over x squared minus 9. Second case is that the degrees are the same. Okay, now you need to do this step also anytime you can. If you can factor their denominator, which in this case you can, remember x squared minus 9 is the difference of squares. It's really x plus 3, x minus 3. You need to do that because the first thing I ask you every time is, what makes the bottom 0? Because that's your vertical. Okay, this time what makes the bottom 0 is negative 3 and positive 3. So I'm going to draw a vertical asymptote through negative 3 and a vertical asymptote through positive 3. Just like that. Now, this time I'm looking at my degrees because I'm checking for my horizontal. The degree is 2. The degree is 2. If the degrees are the same, you do leading coefficient over leading coefficient, which means my horizontal asymptote is y equals 2 over 1 because those are the leading coefficients, which is just 2. So I'm going to draw a horizontal asymptote right through 2. And so I'm going to figure out what my graph does around those asymptotes. So I went ahead, the same thing I did a minute ago, went ahead and punched things in my calc. Oops, I can't make that one big. Sorry about that. But you can see right there, hopefully on your screen, how I punched that first one in. The second one, I can't make that bigger either. Wow, I thought I could do that. I'm trying to get this back where it was. Okay, that's actually that's fairly close. A little bit this way, let's see. Okay, that kind of took it back, I think. No, it didn't. Okay, sorry about that. Wow, thought I could just highlight that picture. But, so, what I need are points in between those asymptotes. So, I don't know if you can see my table down there. Notice it says error. It's always going to say error where your vertical asymptotes are. And so what I'm looking at are some points around those, and I see negative 2 and negative 1.6. So I'm going to graph that, negative 2, negative 1.6, which is like right there. I also see 0 zeros on there, like that point. I see 2 and negative 1.6, which is there. So I can kind of tell what it's going to do in the middle. I need to see what it's going to do over here. So I'm going to pick like negative 4. Negative 4 is 4.6, which is about right there. And also negative 5. If I look at negative 5, it's 3.1, which is about, just barely over the asymptote, about right there. So here's what's going on here. On this side is doing this, because it's going to get closer and closer to the asymptotes. In the middle is doing this. And I got to figure out what's going on the right-hand side over here. So I'll look at like 4. Positive 4 is 4.6, which is about here. And positive 5 is 3.1, which is just barely above the asymptote over here. So it's doing this. Okay, there's your graph. Now, domain and range. Going to be kind of crazy this time. The domain, I'm running out of room here. Let me just shrink all this down a little bit. Sorry about that. I just messed up my picture, but that's okay. Domain, look at your picture. Actually, the domain from left to right is going to skip 2 numbers. So I'm going to do it this way. I'm going to say all x that x cannot equal. It skips the negative 3 and the positive 3. That's where my asymptotes are. The range, it is going up and down forever. So I'm going to say y is going y, but it cannot equal. Notice that the horizontal asymptote is at 2, so it cannot equal 2. So here's what's going to happen every time. Your domain is going to be whatever your vertical asymptotes are. Your range is going to be what your horizontal asymptotes are most of the time. Okay, last one. See if I can do this a little quicker and better. Sorry about that mess up on the last one. I'm trying to move stuff around. This one says that y equals x squared plus 3x minus 4 over x minus 2. So first thing I'm going to ask you again is what makes the bottom 0? 2 would. So your vertical asymptote is going to go right through 2. Just like that. Now this time, your top degree is bigger than the bottom degree, which means there's no horizontal asymptote. Okay, there's not one. So we don't have to worry about that. So I'm ready to start graphing. You can see hopefully on your screen where how I punched it in. It's kind of important that you punch it in there correctly. Hopefully you can see that. I'm gonna try one more time here, see if I can just make that one picture. Yeah, there we go. That's how I punched it in. It's exactly parentheses around the top and parentheses around the bottom. Then I got this table right there. I was working now. I got that table. So those are the points I'm going to use. Notice my error. My error is the asymptote. And you can also scroll down on your calculator. It's going to get more points if you want to. So here I go. I'm going to start graphing some. I got 1, 0 as a point. It's right there. I got 0, 2 as a point. It's right there. I got negative 4, 0. It's over here. And I got 3, 14, which is like out of my picture. It's way up there somewhere. I got 4, 12, which is also out of my picture, way up there somewhere. 8. That's probably enough. I could tell my graph's gonna do. And you can hit graph on your calculator if you want to and kind of see what your graph's doing. But this is the kind of shape it's making up here. Sorry, it's kind of doing this, getting closer to asymptote, and it's heading back up, kind of like that. And again, you can hit graph to kind of check your graph, but make sure you put 2 or 3 points on each side of your vertical asymptote, just like we were doing Monday and Tuesday. Okay, one quick summary here and we're done. It's been a little bit long today. First of all, x-intercepts are what makes the top 0. And I didn't make a big deal, I should have, going through there, but whatever makes the numerator 0 is where it crosses the x-axis. If the top degree is larger, let me say this about the yellow sentence first again. X-intercepts are what makes the top 0. The reason we didn't make a huge deal about that is because we're using the table function on the calculator, and they show up anyway, so it's not a humongous deal. If you were in a situation you had to do all this by hand, that would be a big deal. The green sentence, if top degree is larger, there's no horizontal. That's what the last one we just did was. The red one, if the bottom degree is larger, then the horizontal asymptote is the x-axis. If the degrees are equal to each other, the horizontal asymptote is found by doing leading coefficient over leading coefficient. And don't forget the bottom, the white part. The vertical asymptote is still whatever makes the bottom equal 0. Okay, so that's what we were doing the other day. That's still there. So really 4 rules for graphing these things, and then let your calculator do the rest. So hope that makes some sense to you. If it didn't, hit me up for some help on your assignment today. It won't be really long. And again, we'll do this again tomorrow. So hopefully by the end of Friday, you'll have it down perfect. See ya. And before I say see ya, I'm back again. Your assignment will either be a Google Doc again or it'll be on Delta Math. It depends on how good Delta Math looks. So look for one of those. See ya. Really see ya this time.